So hello all, welcome to the tutorial session 9 on structural analysis. So today we'll first start with a brief recap of week 9 lectures, where you must have gone through three movement theorem, or it is also known as Clapeyron's theorem of three movement. Followed by unit load method, or the method of consistent deformation for beams and frames which are statically indeterminate in nature. So previous week, we have discussed this method of consistent deformation. Or which type of structures? Trusses. So this week or this lesson will mostly deal with beams and frames. The method is same, but the application of the method to different structures will be different. Previous week we discussed trusses, how to use the method of consistent deformation to trusses and deal with statically indeterminate truss. But this week we will discuss about how to determine or how to analyze statically indeterminate beams and frames using unit load method, which is also known as method of consistent deformation. And we will also deal with three movement theorem, which is a force method. So can you tell if this method of consistent deformation is a force method or displacement method?
Sir, it's a force method.
Force method. So let us do again the same brief recap of force method. I am doing it quickly because previous week also we did the same thing.
Yes,
In
sir.
force method, generally the unknowns are forces, as we know. After we know these forces, the analysis means if the DSI of the truck or any member or any structure is, suppose let us say 2. If anyone tells you that two forces, that suppose P1 is 1 redundant, P2 is 1 redundant. Suppose P1 is 1 kilonewton, P2 is 2 kilonewton. Suppose those are forces which are redundant. If you know these two forces, then analysis of the complete indeterminate structure now boils down to applications of equations of static equilibrium only. With the use of static equilibrium, you can analyze the complete structure if you get those values of unknown forces which you have taken redundant. So here the forces are unknowns we generally take for force method. What is the method? Means in displacement method, if you are telling the displacements are unknown, that may be displacement means that may be rotation or that may be deformation in displacement method. In force method, if anyone says that may be force, the unknown may be force or the unknown may be movement. So these two you can take as redundant and analyze the complete structure using force method. So here the unknown are forces, that is the step 1. Second step, or the second step of this force method is compatibility conditions of the structure are taken into account and are satisfied to calculate the unknowns with, and the unknowns here are forces or moments, which you will take as redundant. Now, this is the most important point, because if DSI is less than KI, then your number of equations, suppose you have 3 DSI, DSI of a structure is 3, then you will have 3 unknowns. And using compatibility condition, you have to formulate those 3 equations and solve them. If DSI is less than kinematic indeterminacy or the degrees of freedom, then force method is preferable because it will substantially reduce your calculation and it will be easier. Hence, it is preferable. Vice versa is not true. Means it is preferable, but you cannot say that if if DSI is more or KI is less, then force method you cannot use. You can use force method, but the task will be tedious and it is moreover not advisable to do using that method, because anyhow the task will be cumbersome and it may arise that at some point of time you can do some calculation mistake. So better to first calculate DSI and KI of the structure, then see if the DSI is less than KI, then close your eye, think of force method, which force method you can use, directly pick that force method, and using the steps of force method, you directly analyze the complete structure. So these are the various force method, that are method of consistent deformation, strain energy method, free movement method, flexibility matrix method, and Coulomb analogy method. Today our main discussion will be method of consistent deformation for beams and frames, or more generally flexural members. Previous week, which type of members we discussed? Those are trusses. Those are axial members.
Yes, sir.
Now, the method of 3 movement we will discuss after we discuss the steps of method of consistent deformation. Then, followed by, we will do some questions which will make you more comfortable with this force method and its analysis. So, let us proceed further. So steps to analyze statically indeterminate beams as well as frames. Here I have written beams. It can be applicable to frames as well. By method of consistent deformation. So the step 1 is you have to find the DSI of the beam or frame. Once this step is done, identify the redundant of the structure. Means if the DSI is 1, then there will be 1 redundant. If DSI will be 2, then there will be 2 redundant. Means DSI number of redundant will be equal to the DSI of your structure. After you have identified the DSI of the structure and you thought that this force or this movement I will pick as redundant. Make sure that your redundant you chose are such that the overall structure remains stable after removal of the redundant forces or moments, if applicable. Once you have taken out all those redundant, that structure is called as your primary structure, and primary structure should be stable and statically determined. So the fourth step is that only remove all those redundant such that the structure remains stable and statically determined. This first and this second, these 2 points you should keep in mind every time while you are analyzing any structure using force method, because these are the backbone of force method. If you do mistake here, then your whole answer will be wrong. Now, apply unit load. Where to apply unit load? From where you have taken out that redundant, in that point, you apply the unit load and calculate forces in each member. Here, forces in each member will be calculated due to what? Due to this unit load. You should take out all those external loads and apply unit load, then find the force in each member. Like what we have done for trusses, K force system
Then P force system.
and P force system. In beams and frames, there won't be any type of K force system and P force system. We will see in subsequent slides what are those forces or movements if we take, how the equation will change or modify. K force system in trusses, this is for truss, was due to this unit load removing all external loads, and P force system was due to external loads only after removing what?
Redundant.
Redundant. Means P force system is on primary structure and K force system is also on primary structure, but removing all those external loads. Now, this is the main point again. How to apply compatibility condition, it will come with practice. And you have to visualize the structure such that you can get hold of this compatibility condition. And after that, you need to determine the redundant force. Once those redundants are done, means you are done with that DSI of the structure. If DSI is 2, now you know those redundant force. Now the structure become statically determinate. Why statically determinate? Because those two forces will act as external loads. Means initially it was force, it was reaction. That reaction you don't know. Now using compatibility condition and analyzing by method of consistent deformation, you got those values equal to the DSI of the structure. If DSI is 2 or DSI is 1, you got 2 or 1 unknown member forces. Now you know the value. Now, if you know the value, now the entire structure become what? Statically determinate. Now you can use the equations of equilibrium to determine what?
Member forces, support reactions.
To determine all the aspects of the
Structure or truss.
Let it be bending moment at any point, let it be member forces, let it be reactions, let it be shear force, let it be axial force, anything.
Okay, sir.
This slide is clear.
Yes, sir. Yes, yes.
Next come to our second theorem, that is free movement method. I hope you have gone through lecture 42 or 43 where sir has done the entire derivation. So I want to ask, means I want to know from your side what you have learned from this lecture. After you tell me, then I will proceed. Please open your mouth.
Yes, sir.
Otherwise,
Yes. Actually, we need to determine the unknown. Means the as the method said, three movement.
yeah. Means I am asking in forms of question. You just tell yes or no. Okay.
Yes.
If there is movement, word movement, can you use
Yes.
this method to trust?
No, sir.
Why no?
Because if we normally bend the truss, because normally shear force are bending moments and not generated in the trusses. If we try
Trusses means
to
trust members are, you want to tell trust members are axial members. They won't take any shear, there
movement,
won't be any shear force and bending moment. That's
yes,
correct.
sir, yes.
I agree. After that, you tell.
If we try to bend the truss, then it will simply broke from
Yeah,
any of the.
means uh, in the first lecture, I told you that there some structure is there in the field, and we are analyzing some structure. So, are we analyzing the field structure as it is, or we are doing something and after that we are analyzing?
No, sir, we have uh, assuming as it as a means what?
One word I have said,
Yes, sir, yes.
idealization.
Idealization of structure. Yes, sir.
Idealized
Uh,
structure.
I-
We are idealizing the structure from the real field and we are making it in our copy or anything, then we are analyzing in the simplified. So the
yes, sir.
basic assumptions, when I have taught you that trust chapter, there was a basic assumption that all the members are straight and loads are acting along their longitudinal axis. But do you think in the field uh, all the forces will be axial in nature?
Not exactly because
Yeah, there might be chance that some forces might be eccentric, which will try to bend the truss.
trust.
But from idealization point of view, we are simplifying our task. We are making an idealized structure and we are analyzing it.
Yes,
So,
sir.
in trusses, if we are saying the truss is a axially means axial members are joined together to form a truss which can safely withstand the load given to it and transfer to the supports. Then in truss there is no concept of movement. So this method is generally applicable to beams. Okay. Now, to be more specific, this method is used to analyze the statically indeterminate. As we know, we are discussing statically indeterminate. The concept of force method is for statically indeterminate structures only. So statically indeterminate is the first part and it is used for fixed beam and continuous beams. And one more thing you should note down, the structure should have how many spans?
More than one.
Why one span can't be taken? More than
Uh,
one is okay. More than one is okay. If there is a fixed beam, Can you do it using three movement method?
No, sir.
See, in case of fixed beam, you have to assume one more beam which is not there, which is virtual, having moment of inertia to be infinite.
Infinite.
And so now you got
Yes, sir.
here, suppose A naught, this is A, this is suppose
B.
C naught,
C naught.
A naught half. Now you got, now see, this, here there will be movement, here there will be movement, and here there will be movement. At a time, you have to consider two spans. First, A naught A and A C you can consider. You will get one equation.
One.
Then A C and C
C naught.
C naught C, you will get one more equation. So can you solve?
Yes, sir.
So one span is also, it can be. Now let us see. Now we have taken a structure, means the structure is like, it is expanding in this direction also. There is some branches in this direction also. We have dissected it and we have taken the enlarged version of that. Now see. Now I asked one question. What from that derivation in lecture 43, I guess, what you learned? Means how three movement method, why three movement method is called force method. Now you know what is force method. In force method, you take unknown such forces or movements. So why three movement method comes under the forces method, means force method.
Because if the number of spans can increase, if we increase the number of spans, then it will be more rigorous analysis. Means we have, for every two span we have to carry some set of equations, then we have to carry, then we have to draw fixed end movements and bending moment diagrams.
Yeah.
So
now you
I
are
think,
telling the disadvantages of three movement method. I am asking the other way around. My question is, I am rephrasing my question.
okay.
In what way this three movement method, why this three movement method is called as a force method?
Achha.
These are all small things, but all these points, if you keep in your mind, then at some interview or at some point of time, this will click and might be you will be in a good position to answer. That's why I am highlighting all those basic things up front, because solving the question anyone can do. But visualization is not everyone's cup of tea.
Okay, sir.
Now, see, tell me if this structure is statically determinate or indeterminate. Statically
indeterminate.
Indeterminate. See. So, if you will draw the elastic curve for this beam might deflect like this. If this load is more, then it will go downward and this side will try to lift. Correct?
Yes, sir.
Now, see. You can see at this point, how much rotation to the left, that much rotation to the right. It is means from this mean position, if theta b is the rotation there, this should also be theta b.
Yes, sir.
Correct? Now you tell me, at this point, there should be some bending moment or not?
Yes, sir.
There should be some bending moment. I don't know. Means there should be, I am telling the bending moment is like this and the magnitude is mb. Correct?
Yes, sir.
Now, three movement. So, in this method, it is a subset of force method. In force method, they have told, means in method of consistent deformation, we don't know which redundant you want to take. You choose your redundant in such a way that the structure becomes statically determinate as well as what?
Stable.
Stable. Okay. We don't
Yes, sir.
know which redundant you want to consider and analyze the structure. We only know you have to consider redundant such a way that it should be stable. But here, your redundant is fixed. But in this method, your redundant is fixed. You have to consider the movement or the bending moment, to be specific. Bending moment at this point, inner support to be 0. Means 0 means you are considering as that as redundant. So you have to remove it. So how your structure get modified? Now, there comes what? Internal hinge or bending release. Now you tell me, if you will apply load here and load here, okay? Now, under this load, this beam will deflect like this independently.
And this will deform independent.
This beam will deflect
Independent.
independently.
So
Now, is there anything like theta b should be equal, means right side and left side theta b should be equal? Can you tell any compatibility condition here?
no, sir,
No.
no.
No. Now, you released, this become a statically determinate structure having some theta, and this side also having some theta. You got?
Yes,
Means
sir.
from here, this side became a statically determinate beam. From this side, it is also become a statically determinate. So you calculated the M by EI diagram. Let the M by EI diagram for this span AB is this one, and for BC is this one. And why the bending moment at B is 0?
Because we have assumed that there is a hinge and the hinge cannot transfer moment.
Yeah. So you got now how the mechanics behind those concepts got evolved with time.
Yes, sir.
Yeah.
It's a very
Now,
interesting.
now once this part is done, you formulated the M by EI diagram. Now, what we are doing in force method? We are applying unit force or movement
Unit force.
depending upon the type of redundant we have chosen.
Choose.
So here also, you will again give unit movement. Okay. And calculate those rotation again. Means you giving that unit movement, you calculate rotation and you calculate rotation here. And make sure that each rotation you calculate it will be easier to calculate if you calculate using the method of what? Movement area method. If you
Moment area.
calculate using movement area method, it will be easier. But now you check. We have given bending release, but in the real structure, do we have any bending release?
No.
No. Now from this, what compatibility is coming?
Moment compatibility.
Theta from this side should be equal to theta from this side.
This side.
Okay. Or
Yes, sir. Yes.
if you are writing in the other way, one is clockwise and one is minus clockwise, taking sign consideration, you will write theta b will be equal to minus theta. Means if this is theta b and this is theta c, you will write theta b will be equal to minus theta c. Okay.
Yes, sir.
Means this theta b I am telling not with respect to loading, both with respect to loading as well as with respect to unit movement. Means you calculate, means if it has two components, theta b1 plus theta b2, this theta b1 is due to external load, this theta b2 is due to unit movement, and that should be equal to minus theta c1 plus theta c2, due to theta c1 will come due to this external load on the primary structure, and theta c2 will be due to what? Unit movement you have given as a redundant. Now this is the compatibility condition. When you put all those values of theta b and theta c, and you will manipulate, not manipulate, you have to rearrange all those things, then you will get this equation. And this is the standard equation. You have to remember all the time because you cannot derive. Means you can derive, but it will take more amount of time, and that is not even a good estimate to derive everywhere. So you have to remember this. And remember is easy. You just see. This point is A, this point is B, this point is C. So, and one more thing. This was due to external load only. Now, there might be a chance the support might settle. So, if support will settle, then those rotation which are coming, that might be affected, or that might get reduced or increased depending upon which way the support is, or which support is getting settled with respect to the nearby or neighbor supports. So with that way, there will be some relaxation in this rotation due to unit movement and external load, or there might be increment also. But that we don't know. We will consider what we will see if initially A, B, C were on same height. Now, this mid support got settled down by some amount, such that if you consider B as your datum, then A is elevated to HA and C is elevated to HC. Now, again apply movement area method, then calculate this rotation with respect to original, how this rotation, what is this value of rotation. Then again, there will be one more component, theta B3 due to settlement. And here also that will be theta C3 due to settlement from this side. Now, now all these things are done. You have applied the compatibility and you will get this equation. Now let us see what are there in those equations. What are the unknown? Now MA is moment at A, MB is moment at B, MC is moment at C. L1 you will be knowing, I1 you will be knowing. These are geometric parameters. L1, I1, L2, I2 you will be knowing. L2, I2 you will be knowing. All these are geometrical parameters. see the denominator L1 I1, L2 I2, L1, L2, all these you will be know. Now, A1 will be the area of the bending moment diagram for this given span under a given load AB. And A2 will be the bending moment diagram for this span BC for the primary structure. This bending moment diagram has been done for primary structure, due to which you can see this here at the junction or at the mid support, the bending moment is 0 because we have installed or we have assumed there is a bending release. So you got the idea about A1, A2, and
A2.
this A1 and A2 will be the movement of area of this bending moment diagram from this support A and from this support C. A1 will be calculated from this support A and A2 will be calculated from this support C. And these are nothing but centroids of this bending moment diagram. Now, E you know, modulus of elasticity, and HA. HA and HC. HA and HC
Support settlement.
Will come, these two parts will come if there is support settlement. If not, they are simply 0. Now, the next question comes, how we will take the sign convention. So, come to that part. Now, MA, MB and MC, you have to always consider them to be clockwise positive or positive if sagging, because we generally take bending moment sagging to be positive. Got it? Now,
Yes, sir.
HA and HC. Now, go and stand in the mid support and see with respect to your position if joint EH is at higher elevation or lower elevation. Similarly, joint C is at higher elevation or lower elevation. If they are at higher elevation, then they are obviously richer. Then you can think they are obviously richer, so it will be positive. If they are at lower elevation, it will be negative. This thing is done. You got an idea about sign convention?
Yes, sir. Whatever you have written MA, MB and MC. Positive if sagging. Then what is written there? After
Positive
sagging.
Is sagging.
Then
this is because.
Oh. Because
they are bending moment, and in first class I have said bending moment positive will be sagging. That is our sign convention. That is the reason these are bending moments. Na MA, MB, MC are what? These are bending moments only, right?
Moments. Yes, so,
sir. And every time, if we don't know how the reaction will come, so what we assume? Positive direction only. Correct?
Yes, sir.
So if we don't know, here we don't know how MA, MB and MC, what their values will come. So what we will assume? We will assume that they are, this MA, MB and MC are
positive.
That is the thing it has been written. So now are you comfortable? We will solve some questions now.
Yes, sir. Yes. Definitely.
Now take this question. So are you giving the exam this time, NPTEL exam?
Yes, sir.
NPTEL exam, you are enrolled for NPTEL exam or not?
Yes, sir. I have enrolled.
Yeah. So read this question, because why I have asked, there you need accuracy as well as you need to calculate it more faster. This is question number 1. Here, Read the question. Shown below is a statically indeterminate beam. And this is a linked type question, linked based question containing 3 sets of questions. Okay. So what they are writing? Question 1, question 2, and question 3 are related to solving the beam using unit load method. So unit load method means which method? The other name of unit load method is
Method of consistent deformation.
Consistent deformation. Now they have given, let the redundant be By and Cy. By means this redundant and Cy means this redundant. They are telling, now you first calculate. This much elaborated way the question won't be framed, but this question they have given, so it is fine. Now, what is our first thing to calculate? DSI. So can you say what is the DSI of this structure?
DSI would be 2.
So you got na 4 minus 2. So 2. If DSI is 2, then how many redundants you have to choose?
2 redundant.
2. And they have already given you, they have made your thing more easier by giving you that you have to choose this By as redundant, first redundant or any redundant, and Cy as your other redundant. So they have explicitly mentioned that you choose By and Cy as your redundants. Okay. Now, they have given vertical reaction at B and vertical reaction at C are respectively By and Cy. And they are telling let By equal to x1 and Cy is x2, and this x1 and x2 concept will come in the subsequent question. I think question number 3 we have to calculate. As of now, let us keep it. I don't know what is x1 and x2. Now remove the effect of redundant forces, means remove the effect of redundant forces will give rise to what?
A determinant structure.
What is the name of that structure? Primary structure.
Primary structure.
This is 6 meter. This will be 6 plus 6. A, B, C, 6. From here to here, it will be 24, 6. Now, can you tell what will be the reaction here?
240, 240.
Because the loading and the structure is symmetric, so you can directly light. It will be 240 kilonewton. 240 kilonewton the reactions at RA and RB. Now you cut a section here. You have to write for each section how the bending moment is going to vary. Now, means I am trying to give an analogy between truss and beam or frame and how they are interrelated, or how they are analogous, how the process of analogy is going between truss member and frame member. In truss, you are making a primary structure. Suppose your truss was like this, and this was indeterminate. So you are releasing this. There are two reactions. Let us release this CX. A, B, B, and C. I am releasing CX. So I am modifying these two roller. Now this is your primary structure. Now, if this is your primary structure, now you apply, means there will be some external loads also. I am not showing. So your external load, if some external load is acting, but you will under that external load, what you will get? P4 system.
Yes, sir.
And now, after releasing that CX, you apply 1 unit load here. Because you don't know the value of CX. The only thing we can assume, you can assume anything, but that will create problem and you cannot correlate the things and you cannot keep it intact. So it's better to assume as unity. So under this unit load, there will be some displacement of this joint. Okay?
Yes, sir.
So under this, due to this 1 unit force or load, there will be some reactions coming in every member. That will be K4 system. So think of method of virtual work or Maxwell's theorem. What we have written, external virtual work done should be equal to internal virtual work.
Virtual work done.
So external virtual work done will be 1 into this. Let this point C went or moved by a distance of delta. So
Delta.
external virtual work done is 1 into delta. Due to this 1 unit load, what are the reactions generated at each and every member? That will be given by K4 system. Correct? And due to external loads, there will be compression and elongation of the members, and that compression and elongation of axial members is given by PL by A. So this K4 system is coming due to this 1 unit external virtual load, and PL by AE is the real displacement or real compression or elongation or displacement in general coming for each member. And this P, this 1 unit force when you are applying, let us say this, due to this 1 unit force, this member got some force like K1, K2, K3. Throughout the member, the force is constant. Agreed? If that is constant, then you can sum it off for each member. Then it will provide the total internal work. So in that way, what you got? You will get delta. Now, again apply compatibility. What will be the compatibility? This point is not moving anywhere. So how come you are getting delta? And that delta is due to external load. Now, remove external load. You have applied that 1 unit load. Due to that 1 unit load, there will be some displacement at that joint. So what we are writing, that as F11. What does F11 represent? In the previous class I said that is displacement at joint 1 due to unit load at 1. So you will calculate F11. But was your original reaction unity? Ask.
No.
No. It might be one. I am not telling it won't be one. It might be one, but we don't know. We know that it will be some force Cx. So when you multiply F11 into Cx, it will provide the entire displacement occurred due to the original force Cx. Correct? So, but that joint C, is it moving anywhere? It is not moving anywhere. So what you can write? This delta plus F Cx will be equal to what? 0.
0.
Because this is not moving anywhere. So in this way, you are formulating. So now, here, under the external load, you tell me, is the bending moment at this point, any point, are they constant or are they varying? Sorry?
Between
In any
between
point, let this be this point, this point, this point, this point, any point. Take for your simplicity, I am drawing the bending moment diagram also.
the bending moment is vary between and constant. Yes.
Means from this point till this point, it is varying. For
But
this case only, from this point, 240 kilonewton from this point onwards till this point, it is constant. I agree.
yes, sir,
But
yes.
under some different loading condition, you might get like you can get a bending moment diagram like this also. So
Yes,
at,
sir.
at every point it is varying or not?
Yes, sir, yes.
Means at this is a special case that it is constant at this point having 1440, I guess, kilonewton meter. That I am agreeing. But at each and every point it is varying. With some way it is varying, and that will be function of your span length or x.
Yes, sir.
Where x varies from either any support. You make a reference of the support from where you are measuring all those x values. That is done. If that is done, so what you can write? Now you tell me, under this load, this 240 kilonewton load, there will be some displacement or deflection at this point B and C or not?
Yes, sir.
Means under this, not only this 240, due to all the external loads acting, like in this case 240 and 240. So under these 240 loads, under these 240 loads, there will be some displacement at this point B.
Yes, sir.
Agreed?
Yes, sir.
Now, remove that 240 kilonewton external load. Then apply one redundant force which you are taking as unity. Apply this 1 unit load here. Under that load, when you will draw that bending moment diagram, then again you will see that along the length, when you are considering the bending moment equation, and for each span or along the span, it will vary. Agreed? Due to this unit load. Similarly, when you will put unit load at C, you will see the bending moment at each point is varying and is following some equation. That we will see small m, capital M. Generally, capital M, when you will write, that will be the bending moment representative for the external load. Now,
Yes,
there
sir.
is no concept of K force system or P force system. Now,
Yes, sir.
everything we will deal with in terms of
MM.
bending. Now, this M is the you can write analogous to P4 system. Analogous. It is not equal. It is analogous to P4 system of truss. So this bending moment is a representative. This capital M is the representative of the bending moment equation at each and every point and its variation along the total given span length of the given beam. Correct?
Yes,
You
sir.
got M. Now, remove this, what we say, external loads and apply one redundant, make it unity and draw the bending moment diagram. If there is more than one redundant, you have to consider Mi, where I is the number of redundant. It can, if two redundants, M1, M2. If one redundant, it will be M1 or M. Simply M you can write for one redundant. Once these things are done, this M1 also is the bending moment representative due to unit load at a given point where you have removed your redundant. From where you have removed your redundant, when you apply unit load there, removing all those external loads, then how your bending moment is varying. So you got capital M, you got small m. Now what you can write? If you are applying this 1 unit load and the beam deflects like this, and against this 1 unit load, there will be some displacement, deflection delta. So what you can write? 1 into delta. And now what is this? 1 into delta is what? Work done.
Delta.
This will be work done. External work done. Now, now, due to this 1 unit load, how the bending moment is varying throughout the span? Mi. Correct. And this Mi is analogous to what? This Mi is analogous to K4 system of the truss. Now, due to this Mi, bending moment, bending means under this 1 unit load, the beam is getting bent. If the beam is getting bent, then there will be some rotation, d theta. And now here summation won't work because those are not discrete members. You can write for each member K, each member PL by A. Here you cannot write. Here you have to write along the span, your Mi has a equation, suppose 5x or 10x or 10 by 3x, and it is varying between, suppose A to B, it is varying like that. So you have a equation for a given span. So you have to integrate over that span length, 0 to mean span upper lower limit I am writing and upper limit. So Mi into d theta. Now come to this. Your beam is like this. Under some movement, your beam is getting deflected, suppose like this. How to draw? Okay. Now, this is d theta. Now, and this is R. Now, and this is dx. What you can write? R 1 by r equal to d theta by dx. You can write r d theta equal to dx from geometry, because that d theta is very small. In civil engineering structure, whatever we have assumed, those are for elastic response, your rotation or displacement or deflection, those are very small. So you can write r d theta will be equal to dx. Now 1 by r will be equal to d theta by dx. Now m by I will be equal to E by R. And from here, you know 1 by R equal to d theta by dx. So m by EI will be equal to 1 by R will be equal to d theta by dx. So from here, I'm writing it some other place. So substitute 1 by R as d theta by dx. Now what you will get? M by EI will be equal to d theta by dx. Now d theta will be equal to m dx by E. And substitute this here. What you will get? Delta equal to mi m dx by E. Integration over the total. So now you got how those things are analogous to a truss structure. If you got hold of one system, how they are done, the other system is just the analogy. By analogy, there you are finding the K and P. Here you will get small m and capital M. Just you have to form an analogy and remember those things. Now, once you are done with this delta, ask, this delta was due to this unit load. But in your original structure, and this point is going upward by delta. Is your original structure, this B point is going upward?
No.
Downward?
No.
Then you got the compatibility, you got your own answer. What will be the compatibility?
Yes, sir.
Under this external load, you will get DL1. DL1 will be calculated like this, plus displacement at 1 due to unit load at 1. So you will get F11. Now you don't know what is By. You have assumed 1, but was it 1? No. So you multiply with By and that should be equal to 0 because there is no displacement at B. So the things here are, you need to calculate displacement of primary structure due to external load. This will be displacement of point B where you have removed this redundant and applied one redundant at a time. Under that load, what is the deflection at that point due to that unit load? You have to ascertain that value. And you have to ask the question similar way. Was that By? I was applying 1 unit load. Was that By 1 unit? Actually, I don't know.
No.
So they means the thing might be anything different. So multiply with By. And what will be the compatibility? B is not moving anywhere. So the complete sum it up and that should be 0. From here, what you will get? This unknown you will get or not? You got right?
Yes, sir. Yes.
Now, let us solve the question. Hereafter, there is nothing. We will directly put all those values, get the answer.
Get
Okay.
the answer.
Now, this is primary structure. This was 240 kilonewton. This was also 240 kilonewton. So you got 240 kilonewton reaction here. You got 240 kilonewton reaction here. Now, this point was somewhere here. This was B, this was C. And let us give the name D and E. Achha, this is D. So
the D is there.
let this
E,
be E. F. Correct?
Yes.
Now, when I will give a cut here, just tell me what will be M1 there. Just tell me what will be M1 there.
240x.
240x. And that X, if X we are taking from here,
0
that
to
X varies from which position to which position, correct?
0 to 6. Yes.
Now, let us take section here. Now see, one thing, you have to be cautious enough while you are choosing your X values. Okay. If you choose your X from here, you
Yes.
can write the equation, no doubt, at this section also. But while integrating, you have to take care of your limits. Because if you take X from here and you are writing the equation here, bending moment equation, so you have to be cautious enough from which value to which value your X is varying. Correct? Now,
Yes,
for
sir.
example, if you will cut your section here and write the bending moment, suppose M2. Okay. I will take X from here. We'll later modify because we are not going to take it from here because it will further complicate our process. But for your demonstration purpose, I am showing 240x minus 240 into x minus 6. Correct? Here x will be from, tell me. Tell me. 6 to
Sir,
by
please
that
once
time
more.
I am doing primary structure. 6 to?
Sir, please once more. I mean.
Okay. Now, I said you can take x from here only, but
Okay.
what will happen if you take x from here? You have to be cautious enough while analyzing, while giving the integration. While calculating, you have to integrate. And in that, you have to be cautious enough while you are putting your lower limit and upper limit. So here it will be 6 to this B point. It will be 12. Because I know from this, when I give it a cut, this bending moment equation will be remain same till point F. But why I am giving it till point B? Because convolution of due to unit load, you have to write the moment. And there you will see when you apply 1 unit force here, left of that and right of that, the equations are different. So it's better to divide each and every equation at nearby points so that you can convolute easily and give it a integration directly without any further thinking what will the upper limit, lower limit, this thing, that thing, and all. Okay. Now, you see, if we are taking x from here and we are giving a cut here and we are trying to write bending moment here, then the equation is like this. and you will get, after simplification, x will cut, and you will get a constant value. That constant, let it be anything. But the thing is, when you will integrate, there will be a lower limit, there will be upper limit. And
Yes, sir. Yes.
you tell me, integration of this is easy, or integration of, if lower limit is 0 in
Zero.
any
It's
equation, this is easy.
easy. First one. The second one is easy.
Yeah. Second one is easy if lower limit is
0.
if lower limit is
0.
0. So it's better to not, I am writing this and cutting this, so that you should know why not to write M2. I am taking x from E point, and E will, in this x will vary till point B. Now tell me, if we will write the equation, it will be 1440 kilonewton meter. And it is constant. From here it is obvious, E to B. Correct? It is constant, 1440 kilonewton meter. And here x varies from
0 to 12.
0 to
12.
again the same mistake you are doing. 0 to which
Sorry, sir.
point?
6.
I said divide as much as possible, such that while you are doing the convolution of small m and capital M, there should not be much hindrance. So if you apply, after that, what you have to calculate? Small m you have to calculate for this structure. Let our first redundant be that B only. At B you have to apply at B you have to apply 1 unit load. So when we apply 1 unit load here, the reaction will come downward, and the reaction will be 1 2/3 and 1/3. 1/3. Okay. Now you say me, this 1440 is constant till point F, but when you draw bending moment for this, minus 2/3 into x.
I know, sir. It's up to 6.
And minus 1/3 into x. Negative. This will come.
Yes, sir. Yes.
Correct? Now you tell me, this 1440 I know from E to F it is constant. But your E point is here, your F point is here. Between this E point and F point, is your small m value constant? Huh?
No.
So while you are, because your equation is like integration of small m, capital M, means you have to multiply. And
Yes.
for this, your x should be unique.
For small.
X should be unique. From where you are writing, bending moment M1 as 240x, from there only you have to write small m1 considering x from that point or that joint only. Then only the convolution will hold good with unique or same lower limit and upper limit. Otherwise, you have to modify, and that modification you have to change the limits again, and those are blah blah, very much enormous things are there, and we are not going to deal with those complicated things as of now. We will keep it simple. We will try to divide each and every section as much as possible, such that our lower limit and upper limit for given small m as well as capital M is unique and same. Correct? Now, M2 will be 1440 kilonewton meter, and this will vary from 0 to 6 meter.
6 meter.
Now M3 will be also 1440 meter, 1440 kilonewton meter. Now M3, for M3, I am taking X from this side, and your X will vary between which point to which point? 0 to 12 meter. You got it? Now from this point, B point to C point, I am taking this M3 as 1440 kilometer. Now you consider M4. Now, if you will consider M4, now tell me, from which side you should consider M4?
From
Tell me. Left or right? Which
From
side
north.
it will be easier? You can consider from both sides anyhow.
Okay.
Let us consider between this C and F you have to write. So let us consider from right side. 240 into X. It will be. Sorry, it will be 1440. Sorry. And your X is varying from 0 to this CF 6 meter and M5. This M4 you can write from this side also. If you consider X from here also, the same thing will come, because the bending moment diagram you have drawn from C and F, if you will see, your capital M value is constant. You are getting right?
Yes, sir. Yes.
Now tell me M5. What will be the M5? For M5, if you take X from this side and write, will it be easy? You can write directly. And here
Okay.
X will vary from 0 to 6 meter.
6 meter.
You got? Now, in this case, you have two redundant. So, you have to put one redundant at a time as unit and write those. First, our BY reaction was redundant. So, for first case, I have given one unit load in the at that B point, and I will calculate every small m value. Next, what I will do, our CY is our CY was our redundant, so I will put a unit load at C, and I will calculate all those small m's, which you can tell M2 values for each and every spot. So now you tell me, this will be 1/3, this will be 2/3, and your equation or your bending moment diagram will be like this. Now you tell me, if we are writing small m1 for this unit load at B. This is unit load at C. Now, I will cut a section here and I will write the bending moment equation. So it will be minus 2/3 of X. Here X will vary from 0 to 6. Make sure that, because you have to convolute this you have to multiply M1 with capital M1. So C 0 to 6 meter. This will be your lower limit and upper limit. So make sure your lower limit and upper limit are consistent, and it is taken from the x is taken from the same given reference. Otherwise, your answer will come out. Now write M2. These M1 and M2 are not these M1 and M2. These M1 and M2 are like from section to section, like from A to E. This small M1 equation holds good. If from E to B, if you cut a section, this will represent small M2, and that will be bending moment representative due to unit load at 1 or at B, and that will give M2 value. So tell me, what will be M2 value? And now you see from E to B, when we have written, we have taken our X starting from E. So here also you have to make X starting from that same location. So tell me, what will be the M2 value? Tell me.
Minus 2/3, 12 minus x.
Minus 2/3 into
12 minus x.
12 minus x. No. You didn't get the point, I guess. You cut a section here. Okay. You cut a section here. If you are cutting a section here at this point, to the left side of your beam, there is only one force which will provide bending moment at that location. And your x is you are taking from point E to B. Means your x is varying between E to B. E means 0, it will be 6 meters.
6 minus.
Now you tell me, what is the lever arm for this 2/3?
Plus. Yes. Yes, sir. Yes.
Similarly, tell me for M3, where your section is between B and C, and your X you are taking from B, because here also you have taken your X from B. Tell me, M3.
X.
M3
minus
will be
2/3 to 12 plus x minus 2/3 into
12 plus X, then plus X, one more. This load also will give rise to some bending moment, na?
minus 1 into x.
Plus 1, minus 2/3.
Yes, sir. Plus.
1, sagging.
Yes, sir.
So this is come upon simplification, it will be minus 8 plus x/3. Or x/3 minus 8 you can write. M4. Tell me. Till B, C it is done, na?
Yes, sir.
0.
Then between C and
between
F.
C and F.
F.
You take x from this side only. Now you tell me.
Minus 2/3. 24 plus x.
24 plus x.
Plus 1 into 12 plus x.
Oh. Wait. These 240x and this 240x is coming when we are taking our x from C to F in this direction.
Okay.
in this
And then
direction. So now if our x is taken from this direction for C to F, here also you have to take in this
okay.
direction. So now tell me the equation from the other side. What it will be?
Plus
Minus 1
plus
by 3.
minus 1 by 3 plus 12 plus x
12
sorry
plus
6
x.
plus 6 plus x.
Yeah.
I'm really sorry.
Now M5. Now for M5 you have taken x from this side. So you will take x from this side again. It will be minus 1 by 3 into x. Correct or wrong?
Yes, sir.
I think you got confused somewhere.
No, sir, no. Means there is this question is too long. That's why.
It will be because DSI is 2. So it will be too long. So now again the same thing you have to write M1, M2, M3, M4, M5 for this structure also. So I am writing, you just check. It will be minus 1/3 x. It is simple. Come to
Yes,
this.
sir.
It will be minus 1/3 into x plus 6. Simple. Between that was between B and A to E and E to B. It was between E to B.
Yes, sir.
It is. This was between A to E is minus 1 by 3x. Between B to E it is minus 1 by 3x into x plus 6.
Plus 6.
And between B to
M
C it will be minus 1 by 3 into x
3
plus
plus
12.
12
And between M4 it will be minus 2/3 of x
x
plus
plus 6 6
6. M5 it will be
2 3 2/3 of x.
minus 2/3 of x. You got right?
Yes, sir. Yes.
Once this is done, what you have to let me
Matrix.
add, not matrix. There are many more things to do. Matrix is the last. Yeah. Now, but they have given you, just see. Calculate the vertical displacement at B and vertical displacement at C of the primary structure. So vertical displacement at B, they have given DL1. So vertical displacement DL1, how to determine? That will be MI into capital M dx by EI.
Yes, sir.
Correct or wrong?
Correct one.
Now you give one at a time, then you have to solve. So you know MI, or from A to E, M1 is this. From A to E, capital M1 is this. Multiply
240.
dx EI
Yes.
integrate from 0 to 6. Similarly, M2 and multiply with
1440.
this dx
Uh,
by EI integrate from span length E to B. Then M3 multiply with capital M3 dx by EI integration from span length B to C. Then M4 into capital M4 multiply by into dx by EI integrate from span length C to F. Then integration span length from D to F. What will be the integration? M5 capital M5 dx by EI. You got? You got or not?
yes, sir. For M4, the unit will be, means the upper or lower unit will be M4. Means it would be start
This
from
M4.
0. Yes, sir. Yes, yes.
Acha, wait. There is a issue with this M4 because in my notes there is something written. Let us calculate this M4. Why
Yes, sir.
my
Yes.
my pencil is not working? So wait for. I am cutting this like because.
Okay.
Let us write it here. M4. If you will write from, let us write from left hand side only. Okay. Tell me. Minus 2 by 3 into tell x plus tell me x plus 24
Where you are writing? Yes, sir. Yes.
x plus
Yes, yes.
24.
24.
We are writing from this side C to F only. Okay.
Hmm.
Let us see. Then plus 1 into it will be what?
12.
X plus 12.
12.
So you just do the simplification. X minus 2/3 of x. So 1/3 of x and it is minus 14 minus 16 plus 12 minus 4.
Minus 8 plus 12. Minus 4.
So minus 4 plus 1/3 of x we are getting, right?
Yes.
But in
X
my
minus 3.
notes, it has been written minus 1/3 of x. So let us this is from if you are taking C to F, means left to right. You just calculate for right to left. If you will do what it will come?
Right to left. Minus 1 by 3 into x plus
6 plus x.
x.
That is the only force.
Yes. But unit would be different in M4. If we from left to right, then the means the limits would be from 24 to 36, I guess.
Nah. Why?
Sorry.
What is your starting position of x?
0, 0,
Ah,
0.
we are
Sorry.
simplifying the things. That is the
Yes, sir.
complicated version you are asking. But in my notes, I have written M4 minus 1 by 3.
Okay, sir. We'll calculate.
Hmm.
Let's see.
Acha, the thing is that
Yes.
M4 I have taken from F to D and M5 I have taken from C to F. Both from right side only. Okay. So
Okay.
means my in here M5 is equal to M4 of my nodes and M3 from right to left. This is M5 of my nodes. Okay.
Okay, sir.
Similarly, means these M4 and M5 are getting interchanged everywhere. This capital M4 and capital M5 are getting interchanged. Here also this small M4 and small M5. Here also small M4 and small M5. Anything. But in my notes also I have taken from right to left. Here also we will consider from right to left. This one. Okay.
Okay, sir. Then replace it by
Ah.
that value. So erase that part from here too. Yes.
This is not. This is the correct correct thing. So you got M5, we got M4, we got here also M5, M4 we got here also M5 and M4 we got. Now small M1 it was minus 2/3 of x. Capital M is 240x dx by ei, and that integration will be from A to E. A to E. A to E means
0 to 6.
0 to 6. Like this, how many parts it will come?
5 bar.
5 parts. Again, M2 will be minus 2/3 into x plus 6 into capital M2 is 1440 into 1 into dx by ei 0 to 6. That is from E to B. Now, again, integration minus 2/3 of x plus 12 plus x into 1440 dx by ei, and this will be integrated from A to E is done, E to B is done, now B to C. B to C is 0 to 12 plus integration 0 to 6, but this side F to C, not C to F, F to C. F to C. So this will be minus 1/3 of x plus 6 into 1440 now last part 0 to 6 from right support. What is right support? D support. D to F. So
Yes.
minus 1/3 x into 240 x dx upon E. So now you can multiply and you can integrate. These are all second order polynomial equation will come. So integration won't be that difficult, I guess. Or should I do? Can you do the integration?
Yes, sir. Yes, but you just tell me the final answer for the sake of verification. I will do later.
The final answer will be minus 198720 by EI.
198720. Okay, let me write it. Got okay. Then DL2.
Now with this,
DL2.
we got only DL1. How to find DL2?
Same, but in the next redundant answers. M1, M2.
We have calculated all M1, M2, M3, M4, M5 for this when unit load is at C. So you just multiply this M1 and capital M1 by EI. This M2, capital M2 by EI. So
minus 1 by 3 into
but
248.
But
Yes.
one thing you tell me, the structure is symmetric. So delta B won't be equal to delta C. DL1 will be equal to what? You removed that roller B. You removed roller C. You have 240 kilonewton which is acting symmetrically. So the beam from its middle, when you will cut and see the deflection profile or the elastic curve, mostly deflection profile would be symmetrical or not?
Yes. So
you have a point load here, and suppose you have a not 1 point load. Let us say you have got 2 point load, 3 point loads. This is L, 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 L. So with respect to this axis, is the beam symmetric?
Yes, sir. Symmetric.
So when you will draw the deflected shape, here, suppose at this, from this point at L by 2, this is delta 1. From at this point at L by 2, what will be the value? It will be delta 2. And this delta 1 should be equal to delta 2.
Equal to delta 2. Yes, sir.
So from this case,
means it intuitively it will be equal. It would be. It have to equal.
It should be equal, not it would be. It should be equal.
Should be equal.
So which option is correct? B option?
The B option.
So when you are solving some MCQ question and the question is becoming very large, you have to eliminate the option first. C option, can C option be an option?
No, never.
C is means before, after reading the question, you can directly eliminate C. But here you cannot eliminate any other option because they haven't given that luxury to you.
They have more equal values.
So you have to calculate one, and after seeing, the first thing should strike that since the loading is symmetric, then deflection at point B and point C should be equal. So why to calculate 2 times? I will calculate only once, and that will be the value for other. Now, you got DL1 and DL2, correct?
Yes, sir. Yes.
That DL1 and DL2 is due to
unit load.
Is due to what?
Unit load.
Due to unit load. Due to external load, deflection at that point after removal of redundant due to external loads.
My bad.
Then what is F11, F12, F21, F22?
Force at 1 due to
reverse your statement. It will be displacement at 1 due to unit load at 1. If you are unable to, again, from analogy, this is force method. F is flexibility. What does flexibility means? Tell me, what does flexibility means? What does stiffness means? Stiffness is force. If you don't means if you are not able to comprehend what is flexibility, just remember one quantity. For me, I also get confused with flexibility, so I remember stiffness. Stiffness means what? Force required to cause unit displacement. Force required to cause unit displacement. Then what will be flexibility? When 1 unit of force is given, then what will be the displacement? If you apply 1 unit load, then what will be the displacement at that point? So what is F11? Displacement at 1 due to unit load at 1. F12 displacement at that node due to unit load at 2. F21 displacement at 2 due to unit load at 1. F22 displacement at that point due to unit load at that point only. Got it?
Yes, sir. Yes.
Now this matrix, all those components, they are telling us to derive. Now, tell me what F11, how we can write F1. It will be M I square dx by EI integration. Same way. Again, give the analogy for think the analogy or memorize the analogy for what truss. How you have developed F11
K
for
square
truss.
P K K
Ah,
into P. That's why
ah,
we need to follow only that.
ah.
First M1, then M1
Ah.
into M2, then 2
There
1.
K is M, P is capital M, that thing, and the summation will be replaced by integration. The same thing you have to repeat for every case, every force method, the same thing will go, but not for free movement. Don't apply those things for free movement. Free
3
movement
moment
is a
0.
special subset of force method. So those things won't come into picture for free movement method. So m1 square dx by ei. So here the F11 is m1 square dx by ei. So when you apply this load, you have to calculate displacement at this point B due to unit load at that point. So you apply 1 unit load, there will be some displacement. Then due to that 1 unit, the beam will bend. Due to that bending, those equations will be developed. M1, M2, M3, M4. Similarly, when at C equal to 1, you will get M1, M2, M3, M4 respectively. Now, so you just have to multiply M1. You have to do M1 square. Means when you are doing F11, that unit loaded B you consider M1 square, M2 square, M3 square, M4 square dx by EI. Integration, this will be the lower limit, how you have written. These things, one will go to lower limit, will go, means lower part will go to lower limit, upper part will go to upper limit. Similar. So here you have to just keep square. Means it will be m1 square plus m1 square dx by ei integration plus this will be 0 to L or 6 m2 square dx by ei 0 to 6 m3 square dx by ei. What will be the upper limit?
12.
0 to 6. And here 0 is from F to C.
The another end.
Similarly, I am not writing this part. Addition of all the three, you will end up getting 768 by EI. Okay. Now, you tell me how to find F22, F12, sorry, F12 and F21, will it be equal or not?
Equal. M1 into M2
M1
or 1
of
2.
B, like you write M1 of C dx by E. B and C represents what you know. I'm writing B for when unit load is at B, and when unit load is at C, that M1 at C represents this, M1 at B represents this. So these two means multiplication, convolution you have to do, dx by EI, integration for that span length. So just you can write Mi and Mj. Here I equal to j obviously, and that in integration from span length lower and upper limit of span length. For this case, you will get 672 by here. You are getting now how to do that?
Yes, sir.
See, what does F21 represent? You have to calculate displacement at C. F21, displacement at C due to unit, means F21, if you are getting confused, you tell me FCB. FCB means displacement at C due to unit load at B. So you have applied unit load at B. Okay, due to this unit load, one unit load, there will be small m's. That small m's for each span we have noted it down here at this column. Now, where you have to calculate the displacement, there you have to apply another unit load. I don't know, because there is some other reaction acting there, but I don't know what reaction is acting there. It might be one, it might not be one, it might be some other thing, it might be some XYZ. But the best thing is to apply one unit load. Correct?
Yes, sir.
One unit load, then multiply with the corresponding unknown, you will get the equation. And is the C point moving anywhere? No, that will be equal to 0. That arises from compatibility equation. And similar way, the same means the system moves like that only. You apply one unit load, due to one unit load, this M1, M1B, M2B, M3B, M4B, M5B you will get. That M1, M2, M3, M4, M5 each K force system. Now, due to C, at C, you have to calculate the displacement due to B. So wherever you have to calculate the displacement, you have to put a unit load, because initially in that main structure, there was some CY reaction. CY we don't know. So just put one unit load, calculate M1C, M2C, M3C, M4C, M5C. Done. One this M1, MI of B's and MI of C's you are done. Then you just club it, convolute it, give a multiplication, integrate over the small span length over which your bending moment equations are consistent. So that only we have done. So option A is the correct option. Till this point, we are not done with our first linked question also. Okay. Now they are telling to determine your redundant reactions. Those X1 was nothing but B, y. X2 was nothing but cy.
Cy.
So you have to determine that by and cy. So now, how to determine by and cy? The same thing it is going. See, from here, these are the equation coming from compatibility. See, DL1 is coming from primary structure.
Yes, sir. 190, 1987.
D1 is coming from primary structure due to external
loads.
And DL1 is displacement at point 1. In our case, it is point B.
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 B, sir, B.
Now, that is going. Now,
okay.
You removed your external load. Now you put 1 unit load at point B. Due to that 1 unit load, there will be some displacement.
Yes, sir.
Correct or not? Since we are putting it upward, then there will be upward displacement, but under that external load, it was downward displacement. So DL1 was downward displacement. Now F11, the displacement at 1 due to unit load at 1.
At 1.
So when you are putting 1 unit load there,
load at B,
there only you have to calculate displacement. So F11. And when you do metrics, when you do this, see F11, F12, F21, F22. When you multiply with X1 and X2, we are not writing X1, X2. Let us do it By and Cy.
By, Cy should be better.
And this is a vector. So when you will multiply, what you will get? F11 By plus F12 Cy plus, sorry, equal to 0. And that DL matrix is there. I am not writing. I am doing for this one. Similarly, F21 into By, F22 into Cy equal to 0. Now, see, displacement at 1 due to unit load at 1. You have applied unit load there and calculated the displacement there. But was your reaction unit?
No.
It was By.
Yes, sir.
So under By, it will, when you will multiply the unit displacement, you will get the entire displacement for that By reaction. Correct?
Yes, sir. Yes.
Now, you see, come to F12. Displacement at 1 due to unit load at 2. You applied unit load at point C.
Yes, sir.
Due to that point C, there will unit load at point C, there will be displacement at where? Some displacement at point B also. Correct?
Yes, sir. Yes.
So, now, you tell me that Cy reaction, you have applied 1. But was that Cy reaction 1? No, it was Cy. So under that Cy, what will be the displacement? Cy into F12. And
yes, sir.
DL1. You are adding DL1. So DL1 represents what? When you have removed those redundant, that By and Cy is equal to 0. So under external loads, what is the displacement? DL1 so when you will DL2. Combine the total, what will be the resultant displacement?
DL1 and DL2.
So what will be the combined displacement? 0.
0 would be coming.
So that is equal to 0. So the system has been framed like this only. And from this system only you can get everything. Now, since we have to calculate x1 and x2, DL1 is known, DL2 is known, F1, this matrix is known. So you have to just write. I am writing it here. Just check 198720 by EI. And minus 198720 by EI. This is DL1 and DL2 plus F11 is 768 by EI. This is 768 by EI. This is 672 by EI. This is 672.
672
into x1. Now check. This 768 by E1 you got for unit load at 1. Due to 1 unit load, what was the displacement? When you will multiply with x1, what you will get? Due to x1 reaction, what will be the displacement at that point? So 768 by E1 into x1 will represent the original displacement due to x1 only at that point 1. Okay. Now
okay,
that
sir, okay.
is coming out to be 0.
0.
So just
We would
like
take EI as common and
x1 and x2 you can write as you if you will take these to that side, it will be, suppose I am writing in terms of notations only. Okay. And if that is you got na? You have to invert this flexibility matrix and you have to take this to this dash. You have to take this DL matrix to right side and just take the inverse of this matrix, multiply it, you will get x1 and x2. So your final answer will be 138 and 138. So option D. Okay. So your value for reaction are 138 kilonewton upward and 138 kilonewton upward. Why By and Cy came equal? Can you tell?
Because of, as we know, the loading is symmetric and the displacement is also
correct.
symmetric.
Correct. Absolutely.
So that's why.
Absolutely. Now,
Wait a 3 moment here.
this question also they are trying to tell, they are asking us to solve using unit load method. So, and they have given, let the redundant, so we have solved first 3 questions. Now, this question also has the same things. And here also, can you tell what is the DSI of this structure?
DSI would be 4 minus 2, 2.
2. So,
Yes,
and
2.
they have said redundant be CY and MC. CY and MC means, CY means here This vertical reaction you have to remove, and this movement you have to remove. Anyway, there is no horizontal reaction, so Hx or Hc is 0. So your redundant structure will become a cantilever beam. Redundant means primary structure, sorry. So this is 100 kilonewton, and this total is 10 kilonewton per meter.
If we apply the displacement method, then it will solve easily.
But for today's class, displacement method we should not discuss, because displacement method we will come later in the next
No, sir.
next
Means I
week,
am
I
asking.
guess.
Means
Displacement method can be used. There is no
means
doubt
if
about that.
in the exam,
Huh?
they ask to
No,
solve
no.
by
They won't give you like solve by this method, solve by this method. In the exam, the questions will be more general. They even won't say you
take it
means
as redundant.
take this as this, take this as that. That much elaborative way the question would be framed. The question will be like, what will be the reaction? What will be the vertical reaction at C? What will be movement at C? So any method you know, in which method you can do it more fast way. That method you have to apply and get the answer.
Okay.
Now you check this question. I am just 10 into 10, 100 kilonewton, 100 kilonewton, 200 kilonewton upward,
Reaction
and this 100 and this 100 will try to rotate the beam clockwise.
clockwise.
So one movement will come. This movement will be how much? 100 into 5 plus 100 into 15.
15.
How much it is coming? 500 plus 1500, 2000.
To 500 into 15. 2000.
2000. Now all those reactions you found. Now what next step is to determine what? Cut the section here, write M1.
Moment
Cut the section here,
M2.
write M2.
Here it would be. Sir,
Cut
shall I
the
take from the
cut the
free end?
section here, write M3.
Sir,
Cut.
M3 I should take from free end.
No, why to take from free end? This is a easier. You can take. I am not telling you can't take. You can take. You can take, and you should also take.
Because it would be a long integration if I take from.
As you said, I have also considered that way. So you have to write M1. M1 will be
200 into
200.
5, 1000.
What?
No. What I am saying.
And this, tell me the upper limit and lower limit. I am writing M1, M2, M3. Just tell me upper limit.
0 and 5.
Now tell me M2.
5 to 10.
No. Tell me the equation also. It is from 5 to
5 to
10.
10.
5 to 10, but I am not
Sorry,
interested in 5 to 10.
0 to
You got na?
0 to 5. Yes, sir. Yes.
These mistakes should not be repeated.
I'll care. My bad.
Tell me M3. And you are
0
more
to
interested in writing from right side. So tell me the equation also. Is it correct?
Yes, sir. 5x square. 5x square.
Is
But
it correct?
it would be, yes, sir. Plus, what limit would be from 0 to 10.
Now you got M1, M2, M3.
M3, then
Similarly,
small,
now what you have to do?
redundant.
Apply the redundant as unit. First structure, this CY was your redundant. So you do CY, which is 1. Next movement. This is MC, which is 1.
1.
Here it is your B. Here, let's see, it is M.
D.
M.
D. M.
Okay. Now you tell me, between this one unit is acting upward, so one unit will act downward. This one and one will try to rotate it anti-clockwise. So a clockwise movement should come, and clockwise movement should be 1 into 20 kilonewton meter. This M will be balanced by 1 M only, and the structure is balanced without any reaction. There won't be any reaction.
No.
Now, tell me, when you cut this section and you write M1 from this side, what will be M1?
1 into X. M1 minus 1 into X.
Minus 1 into X.
No. 1. Shear force 1.
Here.
Right. And the units means limit should be from 0 to 5. Then
Why 0 to 5? Why 0 to 5?
I'm asking for 1. M1.
Achha.
Sorry, M3.
You just tell for CY as redundant, you tell me M1, M2, M3. Similarly for MC, you tell me M1, M2, M3. Let us tabulate it. Tell me M1.
Minus 1 into X. 1 into X.
Is this correct?
Plus 5. 1. Oh, my. X plus 5. M3.
Now you tell me for M3. M3 is it's who is it? You tell me M1, M2, M3. Quick. There is nothing much to think here.
1.
So now you got M1, M2, M3, M1, M2, M3 for both the students. Now, same thing. DL1. How to find DL1? Tell me.
M square. MM into
Not
DL.
M square.
M.
DL1 is due to
external.
Capital M is what representative?
External load.
External load representative. So DL1 is due to external load. So tell me, DL1, 1 was CY. So M's of CY will come. So minus X plus 20. So I am writing 20 minus X plus 20 into capital M was 200 minus 2000 plus 200X dx. I am writing 1 by EI outward because it is constant. plus. And this will be 0 to 5.
5.
From which side? From A to
From 3 and
M. A to M.
MM.
Now you tell me for
610.
second one. Tell me for second one.
0 to 5 minus.
No, no. Tell me the equation.
Yeah, I'm not looking.
Let us simplify it. Twenty minus x minus 5. So 15 minus x. And this will be capital M is 1000 minus 2000. So 200 into x plus 5 is 1000 plus 200x minus 2000 dx. This will be from
0 to 5.
third integration will be from
0 to 10.
direction
From 3 and
from opposite direction.
5x minus 5x square in
So from here, once you do it, you will get minus 193750 by EI. Okay.
yes, sir.
Means the complete objective of today's class was to demonstrate you what are the things, how you can correlate between truss member, statically
beam.
indeterminate truss, and beams and frames. And all those notations, how to calculate and how to incorporate to frame the compatibility condition. Now, once DL1 is known, you need to find DL2 also.
DL2.
DL2 is too simpler.
Because
Everywhere
there is
you
1, 1, 1.
everywhere 0 to 5, it is 0 to 5. Small m's are 1, so only capital M. Capital M, you just see this,
2000
right?
plus 200x.
2000 plus 200x into 1 into
200x. 200x minus
minus
1000.
1000 plus 200x into 1 into dx. This will be minus 5x square dx.
Into 1.
Into 1.
Okay.
So from here you will get DL2 as minus 12916 point 12916 67 by 8 6 by 8. So which option is correct?
Option D.
D. And
It's given downward and clockwise direction.
You tell me, minus sign represent what? Why minus sign came?
Because due to we have assumed the moment.
We have assumed it anti-clockwise, but it came clockwise.
Clockwise.
You got?
Yes,
now
sir,
this question is done. First bit is done. Come to second one. You have to calculate all those
F11,
coefficients.
F12.
F's. Now, you have to calculate F11. So to calculate F11, nothing you have to do. This is the beam. Remove all those. This is 1. Correct? This is node 1. So you write F11. F11 will be M1, sorry, MI of, but you can write due to CY I am writing. C, that subscript CY means those small m's are calculated with respect to CY as redundant. Okay.
Redundant.
dx by EI.
EI.
Integration from 0 to upper length. Now you tell me. One case you tell me. Let us see. We have m1 square. So 20 minus x square dx 0 to 5. Then 20 minus x minus 5 dx whole square integration 0 to into 0 to 10 x square x whole square dx
whole upon EI.
Here you will get what we got 2666 by EI. Once you are done with F11, you are getting an option. So B is the correct answer. Now, if at all you have to calculate F22, what you have to do?
M, but due to the moment.
MI due to MC square dx by
dx upon EI.
Integration
0.
So all m are 1.
Yes, sir. dx EI.
So it will be
5, 10. It's easy. 20.
So it is direct now you can get 20 by EI.
20 by EI.
Oh, F22. So they will form the question like that. There will be some trick like this one.
Sir, yes.
There is nothing. You from means with mouth only you can get till it is 20. But
no,
the
if
first
you calculate
one, but first one I have to agree that you have to calculate. Otherwise, there is no option. Tell me F12. What does F12 means? Displacement at 1 due to unit load at 2. Means here load is movement. I am right telling unit load means it can be force or it can be movement. As we have discussed in the second slide of the today's class. So displacement at 1 due to unit load at 2. Displacement at 1 due to unit load at 2. So you have to calculate displacement at this point due to unit movement. Okay. So due to unit movement means correlate again with truss. Unit movement means unit movement is already present there. Means now it is acting like a P4 system for this F12. Correct? Now you have to calculate displacement at 1. Displacement at 1 means your first redundant along first redundant direction. So you have to apply 1 unit there. That from there you will write M1 means small m for that unit load. You have applied there. Means it will be MI of CY. That is the virtual load you have applied there to calculate the displacement. Na? But this 1 unit load is the P4 system kind of thing. So that this will be mi of cy, sorry, mi of m dx by en. And that you think. Anyway, micy into mim by ei into dx
or
is same as that mim into micy. Anyway,
reverse.
means you just hold your hold your nose like in a straight manner or in a curved manner. Both are different. Both are same, the same way. So you have to just multiply this with this with this, and this with corresponding this of
This.
MC. Means M1 of CI corresponding to M1 of MC should be clubbed, and with that clubbing give a integration, convolute it, integrate from the for the given span length, and you will get that coefficient flexibility F12, which will be
200 upon EI.
200 upon EI. You are getting too quickly. Option B is the correct option. So this part is done. Now, the same thing. You got DL1. You got this matrix. F11 is F22 is 20. F11 is 2666. F12 is 200. You got
And
DL1 as what is
DL2.
the DL1 value? What was the DL1 value? Have you written?
No. Previous. No, sir, no.
Or let that be something. We know this. We know the entire flexibility matrix. The only unknown is x1 and x2. Just matrix multiplication and linear algebra, you will get the unknown value x1 and x2. It's like you have two unknowns, you have two linear equations. Just solve x1 and x2, and the values will be 96.87 for x1, and this is the upper limit. You got it right? Now.
Yes, sir. For frame.
We are already exceeded too much of time. Okay, let us complete this question and we'll stop.
No, sir. 1 from 3 moment.
Okay, I am giving hint for this question. You take the screenshot. You solve it by yourself. Okay. Now, here the redundant is CY. They have said. So once you remove that CY, your I will take the class till 9:15. Is it okay for you? 3 people?
Okay, sir. Okay.
But anyhow, I am unable to complete it within 2 hours. It is not possible. How?
No, sir. Questions are too long means not long means lengthy questions. Long questions are coming.
I don't know how the other people are completing it. Now, see. When you see this structure, now this structure is statically determinate. Correct?
Yes, sir.
Then can you tell me this reaction? And can you tell the movement? This reaction?
Horizontal reaction would be 24 kilonewton.
Yeah, that can be seen directly.
Moment would be 24 into 3. So it's 72. Then calculate. vertical nahi.
And this 72 will be
Anti-clockwise. Good.
now tell me this.
Vertical reaction.
The vertical reaction is 0.
What I am thinking.
Summation of fy, if you will do, that will be 0.
Yes, 0.
Now, once this is done, your redundant is cy. Okay,
Yes, sir.
correct. Now what they are telling that you have to calculate dl1, means displacement for this joint C. How, means by what amount this joint C is going downward? That is our question. Now check, all options are downward, so obviously C is going downward. And from figure also you can say C can't go upward, C will go downward. Now you write M1, you cut a section here, you write M1 here, then you cut a section here, you write M2 here.
M2.
Okay, take X from this side here, X from this side. Now can you tell me what will be M1 value?
24 4x square upon
What will be M2 value?
transfer करियो moment.
Tell me. Correct.
22.
If you are unable to comprehend from this side, you just see there is 72
moment.
only. And if you cut from this side also, every throughout it will be 72. And it will be 0 to 9 meter. You got M1 and M2. You tell me what will be small M1 and small M2. And you have to calculate small m for only one case because it is TSI is 1. So when you have to calculate, you have to put Cy as 1 and remove all those external reactions. So when you calculate M1, it will be 0. And for this, it will be X. If you are compatible with this, tell me, otherwise I will again discuss Y0 and YX. Are you comfortable?
Yes, sir.
Are you comfortable why M1 is 0?
Yes, sir. Yes.
Because this 1 unit load is axial. No bending will come along BC. And that one, when you will shift, that 1 into X.
Vertical.
And this will be sagging. So
Sagging
positive. So now you got M1, M2 capital, means external load, M1, M2 small. Now you have to calculate DL1. DL1 is nothing but what?
M into small m dx upon EI. Minus 2x is 0 hijibo. Minus 72x 0 to 9.
Minus 2x square into 0 dx by EI. Then here minus 72x dx by EI. Integration 0 to 9. So minus 72 by EI will come outward. X square by 2 Integration from 0 to 9.
0 to 9.
So when you will do that, it
72
will
into
come
72 into
minus
18.
2916 by 8.
2916.
Minus
Yes.
represent what? Our
Downward.
assumed direction is of CY is wrong, and it should be downward. So this question is done. Now here, see, here how many components will be there, means what will be the order of flexibility matrix? Tell me. It will be 1 cross 1.
It's written that. But
Means you should understand the order of flexibility matrix depends upon the DSI of the structure.
DSI.
What is the DSI? That will be the order of the flexibility matrix. And this is one of the most typical MCQ questions generally asked. So you keep it in mind. So anything can be asked, but you should, that time your mind should be
very much attentive.
During exam pressure, you should comprehend the things quickly and easily. Now you got DL, you got F11 directly you have to write M1 square dx by EI integration from 0 to L. So,
last time I have given NPTEL exam.
0 square dx x square dx by EI integration 0 to 9, and this is 0. So here it will be x cube by 3 EI is 0 to 9. So 1 by EI you can 9 cube by 3. So what you are getting? 243, I guess. So we got F11 is 243 by EI. This is
1 by EI upon
this is done, right? Now you got DL1, you got F1, you have to calculate X1. One equation, one unknown. So you can calculate X1 as minus DL1 by F1. So
243.
Minus 243, yeah.
243 upon EI, yeah.
So here what you will get? 2916 by EI upon 243. So you will get 12 kilonewton upon. You got this part, right?
Yes, sir. Yes. Minus minus cancel you upward. 12. 2916. 2916. Yes, sir. Yes. I got.
Now hopefully one question of
it was
moment.
easy. Means frame,
this
but
sort of question, if DSI is one, no. Frame question and it is easy, there is no correlation. Because their DSI was 4.
One. Yeah, that's why it was easy.
If I will give you a typical frame which has DSI of 4 and 5.
No,
then
please.
There the order of the flexibility matrix will be the order of DSI. You can think of 5 cross 5 matrix, how you will get, how you will invert that. That is a question in itself. Now,
Yes, sir.
and finally, the three moment theorem question came, and this will be the end of the session. With this, we will stop the session.
Let me, sir. Sir.
Now, check. Let me write the three moment equation.
Sir, but it's I is not equal, but EI is given. Then we have to. Okay,
No,
sir,
no.
you may proceed.
EI is given, E is equal. You got right? So, we got the equation. I am writing the equation of three moment.
4.L1 upon I1. এটা ইজিটা ক্যান্টিলিভার বিম ଥିଲେ অবস্থা খারাপ টু আই sir there is no loading
Yeah.
means may I ask why so
There is no loading a beam without any load. So means the question has been framed like that. So there is
okay
no question why the beam is not loaded. It's
okay
like what can I say? A formwork of a structure. Suppose formwork of a structure has been given and no load has been placed there. That stage.
okay the before casting of roof slab.
Kind of.
Kind
I'm
of
not telling exactly because
exact yes
dead
yes
load will act, but here we are here for our analysis. You must have seen everywhere we assume that our beam or frame or structure is weightless. That is our assumption. I am not telling our structure is actually weightless. Everywhere some G is acting, so every structure has its own weight because materials
yes
are.
sir yeah, if we go
Yeah.
to the real analysis then so many things have to consider
Now, for span, but which two span we should take?
AB and BC
And next,
BC and CD
right. Tell me, MA into L1 is
4.5 I
I.
let
Let us keep it as I.
keep at I
2.
2
2
MB
MB
upon into 4.5 plus 3.75 whole I plus MC 3.75 to I.
Tell me, this part is
Sir, L2 and I2, it would be I, MC.
sorry. Yeah.
The first two will be zero.
Hmm.
It was only given support settlements.
Hmm.
Then 6E into point.
The thing is 6 by 5 mm
10 mm.
Support B is sinking by 5 mm and support C is
Sinking by 10 mm.
so like B is sinking to here. This is 5 mm. Support C is sinking to here 10 mm. So tell me this. What will be A? HA. HA will be what?
5 means mm 0.05.
Plus or
0.005
minus?
plus
Then L2 is?
0.01.
No. What is L2? You tell me first.
L2 3.75.
Then tell me HC.
0.01.
0.01.
Ah, 0.015. Nice.
What I have said initially.
Yes. With respect to B.
With respect to mid
Mid support.
support, how much rise or how much below the other two supports are going.
Carefully I have to.
So with respect to B, C is moving downward by 5 mm more. So minus. This is equation 1. Equation 1, when you will simplify, it will come 16.5 MB. Now you can tell MC is 0 because here is
No.
so MA
No
is
movement.
0. So MB plus 3.75 MC equal to minus 106.
Then it would be.
Tell me.
Means there is a negative settlement of 10 mm. And positive settlement of plus 5 mm.
Means what you want to say me for BC and CD, right?
The relative settlement. I'm asking the relative
For BC
settlement.
and CD, we will write. Now I am writing. See, just MB I am not shouting. I am just writing. Now my energy level got reduced.
Okay, sir. Okay.
What about MD?
MD would be 0 because the end moment.
Plus. Now you tell me what you are telling.
About the support settlement.
What will be this H? Means with respect to speed support, that is C, by how much amount B is above or down? B is above, we know. And by how much amount? 5 mm. So it will be 0.005. Similarly, by how much amount D is up by from C? 10 mm, 0.010. Got it?
Okay. Because the B is already sunk by 5 mm. So that's why
you will get two spans. At a time, you can consider two spans. Go to mid span. See with respect to that mid span as datum, how much the other two supports are, at which elevation the other two supports are there. If they are upward, then by how much? If they are downward, then by how much? Means consider your mid support as base. With that base, how much up and down those other two supports are going. By in that way, plus and minus will come, and in that way, the magnitude will also be defined. Got it right?
Yes, sir. Yes, yes.
So 16.5 option D. Here they have asked from A, B and BC what is the equation. So this is the equation, option D. Now similarly, after solving B and C, you will get 3.75 MB plus 11.25 MC equal to 92 into 10. So option C.
Sir, could you
So
slide the? Could you
uh,
show the?
should I write this for BC and CD again?
No, no, sir. I will calculate.
No, no. What you are calculating? L1 was?
Means,
I am not writing again because one
yes,
more
sir. Yes,
question.
I got it.
So option C you got here. Now they are asking to solve the moment at B, MB.
Hmm.
So you have 16.5 MB plus 3.75 MC equal to minus 106.67. Similarly, you have 3.75 MB plus 11.25 MC will be equal to 1920. When you will solve this, you will get MB as you will get MB minus 48.96 means option A, and MC you will get after getting MP substitute in one equation you will get MC as 187 kilometer. So you take
Then,
this
sir.
question, try this. This is easier question only.
I have to expand
Here,
one span.
you have to take one
Span.
virtual beam which is so rigid that its second moment of inertia is infinity.
Yes, sir. So it would be ultimately zero.
That part is zero.
Zero.
That means M, suppose A, that is suppose A naught. M A naught. M A naught into L naught by I naught, where I naught will be infinity. So that part will be zero.
Zero.
Then you write 2MA times length of that one means it is obviously 0 plus
Zero.
this one plus right hand
3
side plus
3 upon I.
MB times this length of AB.
Yes, sir.
From
Yes.
here you will get one equation, and between
From
AB
there.
and between other two span you will get one more equation. And you know what you know.
We'll get two sets of equation then.
You will get two sets of equation. MA and MB will be your unknown.
Yes, sir.
And MC is 0.
0.
So from here you will, I am just taking the option 6A plus 3B. This will be the first option. C will be your option for this question. When you consider a imaginary beam and AB, next it will be PMA. 14 MB. Acha. They have told to calculate MA and MB. After
MB.
you get two equation, when you will solve, You will
Uh-huh.
get MA to be 5.1 and MB to be 12.3.
12.3.
With this, we completed
It's
the
a long
entire
week.
set of questions. So that's all from my side. Hope you understood all the questions and the concepts.
No, sir. Means in the exam.
You didn't understood the concepts and questions. You said no, sir.
No, sir. Means yes, but means in exam I would prefer displacement methods to more
Ah,
because in college
ah,
I was good
ah,
at that.
everyone is good at displacement method because that is the most convenient thing to do.
As you are teaching, then you have to know everything. But uh, from competitive exam point of view,
Yeah, let me stop sharing. Then